You pick up a ruler, ready to measure something carefully, and then you notice something strange. The ruler doesn't actually start at 0. There's a tiny gap before it there, a little empty space before the first line. And once you notice it, you can't unsee it, because it raises a weird question. If measuring starts at 0, why isn't the edge the 0 point? Why waste space on a tool that's supposed to measure accurately? It almost feels like a mistake. But here's the truth. That tiny gap is there on purpose, and it solves a problem most people never think about. Let's break it down. At first, it seems logical that the ruler should begin exactly at the edge. That way you can line things up easily and measure from the very start. But there's one big problem. The edge of a ruler gets damaged. Think about how rulers are used. They get dropped, scraped against desks, thrown into bags, used for years. Over time, the very end of the ruler slowly wears down. Even tiny amounts of damage can ruin accuracy. And when you're measuring something small, a tiny error matters. So if the 0 started exactly at the edge, a chipped or worn corner would make every measurement wrong. That tiny gap solves this. Instead of relying on the physical edge, the ruler relies on the printed 0 line, a controlled, accurate starting point. So even if the edge gets slightly damaged, the measurements still stay correct. Now here's where it gets interesting. This is why many people are taught something clever in school. If the edge of a ruler is damaged, don't start from 0. Start from another number, like 1 centimeter or 1 inch. Then subtract
that amount afterward. For example, if an object starts at the 1-inch mark and ends at the 5-inch mark, the object is 4 inches long. You're measuring the distance between 2 points, not depending on the edge itself. And that's actually what rulers are designed for, measuring distance between markings, not necessarily from the edge. But wait, there's another reason for that tiny space. Manufacturing. When rulers are made, cutting the edge perfectly is difficult. Even a small cutting error could shift measurements slightly. So manufacturers leave a margin before 0. This allows the printed measurement lines to stay more precise and consistent. In other words, that empty space is helping accuracy from the very beginning. Now think about this. The thing that looks like a flaw is actually a protection against flaws. A tiny design decision made to keep measurements reliable. But here's the funny part. Most people spend their whole lives using rulers without ever questioning that little gap, because it feels normal, invisible almost, until someone points it out. And then suddenly, it becomes impossible to ignore. But the story gets even more interesting when you realize not all rulers are designed the same way.
Not all rulers are designed the same way. Some rulers actually do start exactly at 0, especially high-precision rulers made from metal. These are built with carefully machined edges that are much more accurate and resistant to wear. Engineers, architects, and professionals often use tools like these when precision matters a lot. But for everyday rulers, especially plastic or wooden ones, the small gap is safer and more practical, because those materials wear down more easily. Now, here's something interesting. The same idea exists in many measuring tools. Take measuring tapes, for example. Have you ever noticed the little metal hook at the end moves slightly? At first, that seems broken, like the hook is loose, but it's actually intentional. That tiny movement compensates for the thickness of the hook itself. So whether you're measuring from the inside or outside edge, the measurement stays accurate. Again, something that looks wrong is actually carefully designed. And this reveals something bigger about tools. Good tools aren't just about simplicity. They're about handling real-world problems. Wear, damage, human error,
tiny imperfections. Because in theory, measurements are perfect. But in real life, things bend, chip, scratch, and shift. So designers build solutions into the tool itself, even if most people never notice them. Now, let's think about how important accurate measuring really is. A tiny measuring error in school might not matter much, but in construction, engineering, manufacturing, that tiny error can become a huge problem. Imagine measuring parts for a bridge, airplane, or machine incorrectly by even a small amount. Those errors stack up. And when measurements stack up incorrectly, things stop fitting together. So accuracy matters more than we realize. And that's why even something as simple as a ruler has hidden engineering behind it. Now here's the fascinating part. That little gap before zero is doing almost nothing physically. It's just empty space. But conceptually, it represents trust. It's there so the ruler stays reliable over time. A small sacrifice of space to protect accuracy. And once you understand that, you start seeing everyday objects differently. You realize many simple things around you are designed the way they are for hidden reasons. Not randomly, not carelessly, but intentionally. So the next time you pick up a ruler and notice that tiny space before zero, you'll know it's not wasted space at all. It's a quiet little solution to a problem most people never even notice. Common thing, surprising history, and now you know why there's a space before zero on a ruler.